In this lesson, we're going to look at single replacement reactions or single displacement reactions. The bell ringer for today is review from last lesson where we looked at synthesis reactions. So the analogy that I have for single replacement reactions is the Twilight movies. So in the first movie, we have Edward and Bella as a couple, and then we have Jacob, who's also interested in Bella, but he's just kind of out on the outside. And in the second movie, we have Jacob and Bella as a couple, with poor Edward kind of off to the side. So in this reaction, we had the male characters switch places with Bella. And if you look here, on the left side and the right side, it was only the male characters that switch places. So think of the male characters kind of like the cation in both cases. So single replacement reactions take this form. We're going to follow similar steps to what we did with synthesis, where we first figure out the charge of every ion in the reaction. However, when we get to the second step, it's a little different. So if our C, let me underline this, if our C in this reaction is a cation, it will bond with the anion from the compound. However, if C is an anion, it will bond with the cation from the compound. So we just want to make sure that we always have a cation plus an anion. We never want to end up with cation or anion. We always have a cation anion. Once we've completed that step, we then figure out the ratio needed for the new compound to be neutral, just like we did yesterday. However, this final step is new. So on the product side, if our B here, the lone element, is diatomic, we add a subscript of 2. And I'll explain what that means here in a second. So diatomic elements are never found as a single atom. So we never have bromine by itself. We always have them with a subscript of 2. So below is a list of all of the elements that follow this rule. We have iodine, hydrogen, nitrogen, bromine, oxygen, chlorine, and fluorine. So I have this mnemonic that will help you remember this. I have no bright or clever friends. So I've underlined the element in each word that you're remembering with each word. And if you can remember this, you should be able to remember all of the elements that are diatomic. So when we go to do our single replacement reactions, if we end up with one of these elements as the lone element on the product side, we want to add a subscript of 2. So let's do an example here. So our first step is going to be to figure out all of the charges on everything. So we have magnesium. Magnesium has a charge of +2. We have sodium, which has a charge of +1. And we have chlorine, which has a charge of -1. Okay? So magnesium wants to replace something, and the only thing that it can pair up with is chlorine, because chlorine has a negative charge. It's an anion. Again, our cation wants to pair up with an anion. So when we pair these up, it's going to be magnesium chloride, and in order to get these charges to balance, I need chloride to have a subscript of 2. So again, magnesium has a charge of +2, chlorine has a charge of -1, so we need 2 of them to balance the equation. So +2 and -2 gives us a net charge of 0. Okay, so sodium is going to be left over. Sodium is not diatomic, so we can write it just like that. So at this point, we just need to make sure we're balanced. So I'm going to go ahead and I'm going to erase everything else that we've already dealt with here, so I have some room. And then I'm going to make my table to balance my reaction. So on my right side, I have magnesium, chlorine, and sodium. On my left side, I have magnesium, chlorine, and sodium. So on the right side, I see 1 magnesium, 2 chlorines, and 1 sodium. On the left side, I see 1 of each. Okay. So to balance this, I need, let's see, I need 2 chlorines on the reactant side. So I'm going to put a 2 here. That now gives me 2 sodiums and 2 chlorines. So now my chlorines are balanced, but I'm going to need to put a 2 in front of my sodium here to balance out the sodiums. So everything here is good. As I've said in the past, I don't like to leave things blank, so I'm just going to go ahead and fill in a 1 here on magnesium. That's totally optional. If you want to leave it blank, that's fine, but me personally, I like to fill those in so I know that I've completed everything. Okay, in our second example here, we have potassium, iodine, and bromine. Potassium has a charge of +1. Iodine has a charge of -1. And bromine has a charge of -1. So the only elements that can switch places, or the only pair that I can make here, is between potassium and bromine, because we have a positive charge and a minus charge. I couldn't pair up bromine and iodine because I'd have 2 anions. So these are going to form potassium bromide, and then iodine is going to be left over. Iodine is one of the elements that is diatomic, so I'm going to add a subscript of 2 here. Okay, so let me just make a note here that this is diatomic. Okay, so that's why we're adding our 2 here. All right. So all the charges are balanced, so my next step is to balance the equation. So let me erase this, and then I'm going to make my table. I have potassium, bromine, and iodine. Potassium, bromine, iodine. And I see 1 potassium, 1 bromine, 2 iodines. On the left side, it's 2 bromines and then 1 of each. Okay, so let's see here. If I need to put a 2 in front of the bromines on the product side because I've got 2 bromines on the reactant side. So now I have 2 potassiums, 2 bromines, and then I need to balance out my potassiums. So on the left side, I'm going to put a 2 in front of my potassium here. So now I have 2 potassiums, 2 iodines. And let me just double check. That looks like we are balanced. I'm just going to put a 1 here, and I am set. This one is balanced. All right, here's another example. We have aluminum, and then we have HCl. HCl is a acid. It's hydrochloric acid. Okay, so let's go ahead and figure out our charges. We have aluminum, which has a +3 charge. We have hydrogen, which has a +1 charge, and then chlorine, which has a -1 charge. The only items that can react are aluminum and chlorine, or the only items that can combine, rather, are aluminum and chlorine. So I need 3 chlorines to combine with our aluminum because this is a -1, this is a +3. Okay, so +3, I need 3 chlorines to combine with my +3 to give me a net charge of 0. Okay, hydrogen's left over here. Hydrogen is diatomic, so I'm going to write a 2 afterwards to show that it's diatomic. Okay, so now it's just a matter of balancing our equation. All right, so we have aluminum, we have chlorine, and hydrogen. All right, so I see 1 aluminum, 3 chlorines, 2 hydrogens, and then on the reactant side, it's 1 of each. So I'm going to start by balancing my chlorine. So I'm going to put a 3 in front of my HCl. So now I have 3 hydrogens, 3 chlorines. So that's good. Aluminums are balanced, and I need to balance the hydrogens. Okay. So this happens sometimes when you're balancing equations. Sometimes you have to go back and tweak things because you realize that when you balanced one thing, it messed something else up. So in this case, I have 3 hydrogens on the left side, the reactant side, and I have 2 on the right side. So in order to balance this out now, I'm going to have to tweak my 3 that I just wrote in for my HCl. Because on the right side I have 2 hydrogens. The least common multiple between 3 and 2 is 6. So to correct this, I'm going to go back and I'm going to change this now from a 3 to a 6. So now I have 6 chlorines and I have 6 hydrogens. And then to balance that, I'm going to put a 3 on the right side, my product side. So now I have 6 here. Okay, but I have 6 chlorines on the left and I need 6 on the right. So I'm going to put a 2 in front here. So now I have 2 aluminums, but 6 chlorines. So in balancing one thing, I unbalanced another. So to complete the balancing, I'm going to put a 2 in front of aluminum on the reactant side. And let me just double check. That looks like we are balanced. Okay, so again, sometimes this happens when you're balancing. You have to go back and forth. You have to tweak one thing to fix another. It's totally fine. Sometimes when you're doing this, if you think a couple steps ahead, you might be able to catch that ahead of time. But other times, it's just kind of a guess and check until you get the right combination. Making a table helps because you can see everything at once. But some people are just quick and they can go and just do it in their head. All right, here is our last example. We have magnesium. Magnesium has a charge of +2. We have sodium, +1. And then we have a polyatomic. So NO3 has a charge of -1. So the only thing that can switch here is going to be, or the only thing that's going to combine rather, is going to be our magnesium and our polyatomic. Okay, so when we combine these, I'm going to need 2 of my polyatomic to balance out with our +2 on magnesium, and then sodium's going to be left over. Okay, so let's go ahead and make a table. So we have magnesium, we have NO3, and then we have sodium. Same thing on the other side. All right, so on the left, we've got 1 of each. On the right, we have 2 of our polyatomics and 1 of sodium. Okay, sodium is not diatomic, so we don't need that 2 afterwards. Okay, so to balance this, figured we'd give you an easy one to finish off after that last one, which is tricky. The only thing we need to do here is we need to add a 2 in front of our sodium and then our polyatomic here. So that's going to change this to a 2 and a 2. And then to complete balancing, we're just going to add a 2 after our sodium, and we are balanced here. So if you get a polyatomic, don't panic. I know there's a lot going on here, but remember, we just treat it like it's its own entity with its own charge. For homework, you're completing part 2, numbers 1 to 10 on the worksheet from yesterday. And here's our exit ticket. Complete the replacement reaction below.